Hello and welcome all on Unacademy JEE English, guys, a channel launched by Unacademy where each and every topic for IIT JEE will be taught you in pure English. And today I am Rahul Kaushik. I will take lecture number 3 on Redox and Equivalent Concept. Okay, guys. So, guys, today I will teach you the law of chemical equivalence. What is law of chemical equivalence and why do we need it? Why do we need it? So before this, guys, we have already done how to balance a chemical reaction. I have told you in the first lecture. I taught you how to find out the oxidation number of elements present in a compound, and then in the second class we did the balancing. And now today I'm going to start law of chemical equivalence. So guys, you might be thinking, sir, why do we need it? Why do we need it? And why after mole concept you took redox and equivalent concept? So guys, now I will discuss today. Hello Emmy. Yes. Good evening, good afternoon. So guys, before I start today's session, let me tell you something about myself. I'm Rahul Kaushik, guys. I worked in Bansa classes Kota since 2010 to 2020. So guys, I worked there for continuous 10 years and I was head of department there. I mentored 2000 plus IITians, guys. So after this, I co-founded my own organization, that is Gyan Education Private Limited. And now I'm here on Unacademy to share my experience and knowledge with you guys. Hello Shravanti. Right, guys? So this is all about me. Now guys, if you are planning uh, to subscribe Unacademy, I have a piece of information to give you guys, because now only 2 days are left. And what is that piece of information? I will surely give you. But first, let me tell you how to subscribe that. Step number 1, go to Play Store or App Store, download Unacademy's Learning app. And once you have downloaded it, install it. And guys, after installing, you will be getting this page. So once you are clicking on the plus, you will be getting IIT JEE and NEET UG. So just check the IIT JEE box, and once you are checking it, guys, you will be getting this button. So hit the subscription button, right? And once you are hitting the subscription button, guys, then you will go to payment page. But before going there, guys, let me tell you something. And that is very important for you. Hi Ravish. Hi Ravish. So from 10th of September, from 10th of September, price hike is coming, guys. Right? From 10th of September, price hike is coming. And if price hike is coming, so guys, what you have to do? If you are planning to take subscription plan, then you are left with only 2 days. Hello Monica. Then you are left with 2 days only, guys. So do it. Don't delay. Otherwise you have to pay hiked fees. So now I will tell you what is the hiked fee, what is the fee before 10th September and what is the fee after 10th September. Okay guys, so here, if you are applying the my code, that is Rahul Chem, right, for 1 year you have to pay 27,000 rupees, and for 2 years you have to pay 32,400 rupees if you are applying this code. But guys, after fee is applied or after hike fee is there, then you have to pay 34,650. So guys, you can see the difference. Instead of 27,000, you have to pay 34,000. Okay guys, you have to pay 34,000, extra 7,000, and for 2 years, instead of 32,000, you have to pay 50,000. Right guys? So I hope now you are getting. So if you are planning to subscribe to Unacademy, guys, then this is the right time. To it. And again, if you are applying this code Rahul Chem, you will be getting flat 10% off. Right? You will be getting flat 10% off. And now, what are the advantages of subscribing to Unacademy, guys? What are the advantages? So let me tell you guys, course would be structured. Yes, their course would be structured. You will be given the plan for every course in advance, and then every fourth class will be doubt clearing session. That is very important. Every fourth class would be doubt clearing section, and then there would be weekly quizzes. Then there would be weekly quizzes, and after each topic there would be a mega quiz. Yes, after each topic there would be a mega quiz. And guys, let me tell you again guys, the most important part of any preparation is testing, and there will be regular test, and these regular tests will give you a chance to analyze your performance or where you stand in comparison to your competitors or your peer group, right guys? So I hope now everything is clear. So 27,000 and 34,000 you have to pay currently if you are applying this code Rahul Chem, that will be giving you 10% off, right? Hi Priya. So guys, now let's start today's class. So are you ready guys? Please tell me, are you ready now? Let's start it. Yes. How many of you have revised the previous class? Because I'm going to start it with a quiz with one or two questions. Please tell me guys, how many of you have revised the previous class properly? Yes guys, tell me. I am getting no answers. Okay. So guys, let's start it now. We were doing the redox. In first class, I told you how to calculate oxidation number. Hi Amy. Yes, I know you might have revised it. In the second class, I told you balancing of redox reaction. I hope now everything is clear. Now balancing of redox reaction is done. You are done with it. So guys, balance it. Yes, Amy. Now balance it. I'm starting with some problems of balancing and then I will proceed ahead. Yes, this problem was also done in the last class, but guys, do it now. Balance it. Be fast. Balance it, guys. Do it. So here, first you will write, I'm giving you 1 minute for it. Just try it and then I will start. So guys, here just write down the oxidation states. This is +5, +3 and -2. Here we have this one is +5, +6, +2, right? So here you can observe nitrogen is going from +5 to +2. So reduction of nitrogen is taking place. So write down this reaction here. Write down this reaction and you will have 3 electrons. And then guys, you will be having right. Yes, what I'm doing guys, I'm balancing only those atoms for which oxidation state is changing. So here we have 2 osmium and 3 sulfur. So I have balanced 2 osmium and 3 sulfur, right? Here the oxidation state of osmium was +3 and here it is +5. So guys, just calculate what is the change. Just calculate what is the change. For osmium, yes, for arsenic it is going plus 6 to plus 10, and for sulfur here we have minus 2 and here we have plus 6. So minus 2 is on one sulfur, so 3 sulfur will having minus 6, and plus 6 on one sulfur, so 3 sulfur will having plus 8. So this change is plus 4, this change is plus 24, so net change will be 28 electron. So it will lose 28 electron, guys. It will lose 28 electron. Yes, Amy, you are right. So after this, multiply it by 28 and multiply it by 3. So you will be getting 28 HNO3 and 3 AS2S3 and no, yes, and 6 H3ASO4, 9 H2SO4 and 28 NO. I hope now it is done. So you have balanced nitrogen, arsenic, sulfur. Now H and O is left. Only H and O are left. So now just check. Yes, now just check it. So here we have 28 hydrogen and 84 oxygen. Here we have 24 oxygen, 36 plus 28, 88 oxygen. So 4 oxygen are extra, and just count the hydrogen. Here we have 18 and 18, 36, but here we have 28. So just write down 4H2 on the left side. And now guys, everything is balanced. Now everything is balanced. Right? So do it. Now solve this one. Now here guys, before solving it, I'm telling you, actually H2O2, when its reduction take place, this get converted into water. In H2O, oxygen here is -1 and here it is -2. So basically reduction of oxygen is taking place. And when oxidation of H2O2 take place, here oxygen is in -1 and here it is 0. So again -1 to 0. So oxidation is taking place. And in first case, reduction is taking place. In first case, reduction is taking place. Tell me. Yes, guys. So you should remember when there is oxidation of H2O2, always make oxygen, and when there is reduction of H2O2, always write water. Is that done now? So guys, balance this. Yes, be fast. Balance it, guys. Yes, Amy, Priya, anyone. Balance it now. So again, write down the oxidation states. I'm just giving you hint. 0 plus 2 plus 5 plus 2. Yes. Now do it, guys. Do it fast. Yes, I'm waiting. Be fast, guys. So how will you solve it? Hi, Manish. How will you solve it, guys? राधे राधे भाई शिवेंद्र, यहाँ क्या कर रहे हो? So now I'm doing it. Copper is going from 0 to +2. But guys, here you have to keep one thing in mind. this nitrogen is changing its oxidation state, but here it is not changing. So some nitrogen atoms are changing their oxidation state while some are not changing. So how will you do it? So just do the easy part first. Copper is going into this. So from 0 to +2. So you will just write 2 electron, right? And now do the second part. HNO3 is going into this. This is +5, this is +2. So you will write 3 electron. So here you are balancing only those nitrogen atoms which are undergoing change in oxidation state, right? Not all, because there are some nitrogen atoms which are not changing their oxidation state. NO3 is here as well as it is here. So what will happen now? 3, 2. 3 Cu solid, 2 HNO3, 2 NO gas, 3 CuNO3, right? 3 CuNO3. But still, now nitrogen is not balanced, copper is balanced, and this NO is balanced, but we have 2 more extra NO3. So for these 2 extra NO3 guys, just add 2 HNO3 here. Just add it, right? And when you are adding, not 3, actually here we have 6. 3 into 2. So when I am adding 6, so guys, what I will get? 3 Cu solid, 8 HNO3. It will give you 2 NO gas. And now guys, we have 8. So you have to write here 4H2. You have to write here 4H2. I think now it is done. Yes. Any doubt? Okay guys, so I am giving you one more similar type of problem. Just do it. Let's see how many of you can do it. CuSO4 plus Ki giving you Cu2I2. Yes. Balance it guys. Balance it. Yes, Manish, Shivendra, Amy. So Amy, you were right. Now balance this one, Amy. We have a very good problem this time. Write down the oxidation states, guys. +2, -1, 0. Here it is -1. So again we have 2 types of iodine. There is one type of iodine for which oxidation state is not changing, no change in oxidation state, but there is one more type. So if you have suppose 10 iodine atom, or then 5 may ionize, 5 may reduced, and 5 may not reduce. So guys, how will you solve such type of problems? Yes, do them. Be fast guys, I'm waiting. Be fast. Because after today's class, you should be able to solve each and every type of balancing problem. I'm not getting any answer. So always start with the easy part first. And what is the easy part here? Ki giving you Ki giving you iodine. Ki giving you iodine. So here we have -1 and here we have 0. So there are 2 iodine, -2 to 0. So 2 electrons are lost. Yes, Amy, let's see. And now I will write CuSO4 giving you so here again balance the copper atom. Why? Because oxidation state is changing only for copper. For sulfate it is not changing. For sulfur and oxygen it is not changing. So guys, now what will I do now? Here we have +2. So copper is moving from +4 to +2. So just 2 minus 4 will be -2. So there would be a gain of 2 electrons. Now just add them. You will be getting 2 CuSO4, 2 Ki, Cu2I2 plus iodine. So guys, now you have 2K. So just write K2SO4. But you have 2 sulfate. Yes. Now what will you do, guys? What will you do? Tell me. How will you solve this? Now again, guys, you have to add 2I minus as well. So just add 2 Ki. In that case, you will be having 4K. So you will write 2 CuSO4, 4 Ki, and you will be getting Cu2I2, I2. Now this is done. Now do it. Yes, Amy, again you are right. So guys, should we proceed ahead or you want some more problems over this type of concept? Please tell me, guys. Should we move ahead or you want to solve some more problems? Tell me, guys. Yes. Should I proceed ahead or you want more problem? Yes, be fast. I'm waiting for your reply. Okay, let's take one more problem. Let's take it. Iodine plus will give you. So it is in basic medium. Do it. Yes, be fast. Do it, guys. Do it fast. Let's see this time who solves it. Yes, guys, be fast. Amy, Manish, anyone. I'm waiting for your answer. Yes, this is tricky. And how you guys are going to solve it? If you are taking iodine. So iodine from 0 to going -1 and it is going +5. 0 to going -1 and it is going +5. So guys, you will just write iodine giving you 2 Na. So from 0 to -1, so there will be gain of 2 electron. Yes, Amy, you are right. Now what I have to do is, again, iodine is going into NaIO3 from 0 to +5. So just balance the iodine atoms. So here it is going from 0 to +10. So +10 electron will be here. And you just multiply it by 5. So once you are multiplying 5 I2 and I2, you will be getting 6 iodine, again 10 NaI and 2 NaIO3. Now what about this NaOH, guys? This is providing the basic medium. What about this NaOH? Tell me. So you just have to write. You just have to write. How many Na are there? 12. 12 NaOH. Now Na is balanced. Now just count the oxygen. We have 6 oxygen here. We have 12 oxygen here. So just add 6 H2O here. So we have 12 H and 12 H are already here. So this is the balanced reaction, guys. This is the balanced reaction. You can see it. Yes, guys, tell me. You can see it. Yes, Amy, you are right. Very good, Amy. It seems that your redox topic is very strong. Am I right? Okay, so guys, now solve the last problem and then we will proceed ahead. Now solve the last problem. Yes, this is the last. So guys, just let's do it. Cu3p plus, it will give you, yes guys, do it. Yes. So guys, here we have phosphorus minus 3, copper plus 1. This is plus 6, and here copper is plus 2. Here phosphorus is plus 5 and Cr is plus 3. So now you can solve. Cu is converting from plus 1 to plus 2, so oxidation of copper is taking place. Hello, the shorts guy. Hello. And then phosphorus is going from minus 3 to plus 5. So guys, we will do the easy part first. Take it as Cr2O7, 2 minus. Always take easy part first. So it will be, and it will give you 2Cr3 plus. Now if we are talking about chromium, so here oxidation state is plus 6. So 2 chromium will have plus 12. Here it is plus 3. So it is going to plus 6, minus 6 electron. So there is gain of 6 electron guys here. And then you will write like this. So we have 3 here. So I will balance the copper. Then we have H3PO4. Now phosphorus is balanced. So it is moving from plus 1 to plus 2. So guys, here I can take copper is moving from plus 3 to plus 6. So change of 3 electron. Phosphorus is moving from minus 3 to plus 5, plus 8 electron. So there would be total 11 electron. So 11 electron will be there. And then guys, what you have to do is 6 into 11, right? Work hard and you will be shifted to upper batch. I have seen so many guys getting low batches in the initial phases of their coaching, and then I have seen them in shifting to the even top batches, right? So work hard. So guys, you will be getting 11 plus 3CO2 plus. Yes, actually here it would not be 3. So when you are multiplying it by 11 and 6, so you will be getting 18, 6, and then 11 into 2, 22. Yes. Now this is balanced, guys. Now this is balanced. Any doubt, guys? Please ask if you have any doubt. So again, if you want to balance, again, if you want to balance the oxygen and hydrogen, you can do it. Just count the oxygen atoms here, 24, and here 77, right? Now you know the difference and you can do. Now if suppose I'm saying acidic medium, it is S3PO4 is weakly acidic, so medium would be acidic, so you can do it. So guys, this is all about balancing we have done. Now I'm moving ahead. Guys. What are the types of redox, or I should say types of reaction? Only reaction. Actually, reactions can be of two types. One reaction can be redox, another can be non-redox. So redox reaction can be further divided into three types: simple or intermolecular, decomposition, or disproportion. And then non-redox, it will be acid base, it will be double displacement, decomposition, and complex formation. So guys, now I'm going to discuss all. Just note it down this table. Note down each and everything. Note it down, guys. And then I will proceed ahead. So, what are redox reactions, guys? The first type is redox reaction. What are redox reactions? I've already told you, but I'm again repeating it. These are the reactions in which oxidation state of reactant molecules changes. Note it down. Redox reactions. How will you identify the redox reaction? These are the reactions in which oxidation state of reactant molecules or ions changes. So guys, if I ask you how will you identify the redox reaction, so the answer is simple. Just check the oxidation numbers. If oxidation numbers are changing, then this will be a redox reaction, right? Note it down. So redox reactions are of three types: simple or intermolecular redox. Then we have decomposition or intramolecular. And again, the third one is disproportion. Yes, third one is disproportion. Actually, it is disproportionation. So, what is this? I will discuss this as well, right? So, what is simple or intermolecular? What is simple or intermolecular? So, I'm telling you the simple redox reaction. What is simple? Right, guys? So, if I'm writing Fe2 plus and MnO4 minus, and the product is Fe3 plus and Mn2 plus. So here I am telling you this is plus 2, this is plus 7, plus 3, plus 2. So guys, here you can see oxidation of Fe is taking place and reduction of Mn is taking place. Mn is moving from plus 7 to plus 2 and Fe is oxidizing from plus 2 to plus 3. So guys, if you are writing here Fe plus 2 converting into Fe3 plus 1 electron, now MnO4 minus Mn2 plus. So if 5 electrons are here. So guys, what is going on exactly? Here Fe is losing electron and the electrons lost by Fe are gained by Mn and Mn is gaining electron, right? So transfer of electron is taking place between two molecules. That's why it is also called intermolecular. Why it is also called intermolecular? You might have heard about international. Yes. So what is international? So international match. So what is international match? Tell me. International match is between two nations. So intermolecular means between two molecules. Intermolecular means between two molecules. So what is in between two molecules? So electron sharing occur between two molecules. That's why it is called intermolecular, or other name is simple redox. So what is simple or intermolecular redox? So in simple or intermolecular redox, guys, there will be two reactant. One reactant will lose electron and another reactant will gain electron. So you can also say, guys, this is reducing agent, this is oxidizing agent. So electrons lost by reducing agent will be gained by oxidizing agent. Right, guys? So now note it down. What is simple or intermolecular reaction? In simple redox, more than one reactant will be present because electron transfer will take place between two different molecules. So more than one reactant will be present, in which one reactant will act like oxidizing agent and other will act like reducing agent. One reactant will act like oxidizing agent and other will act like reducing agent. Yes, any doubt? Any doubt? So more than one reactant will be present, in which one reactant will act like oxidizing agent and another, here you can see, this is acting as oxidizing agent, this is acting as reducing agent, right? So because exchange of electrons occur between two molecules, that's why it is called intermolecular redox. Because exchange of electrons occur between two molecules, that's why it is called intermolecular redox. Yes. Now note it down. Because exchange of electrons occur between two molecules, that is why. Because someone might ask you why it is called intermolecular redox. Because it is occurring between two molecules. And I just told you the meaning of international. International means between two nations. I hope you got it, guys. Got it? So now can anybody explain me the decomposition? This is also known as intramolecular redox. So what is decomposition? What is decomposition? In decomposition, decompose means breaking down. So there will be a big molecule that will break down into smaller ones. And this process is called decomposition. This process is called decomposition. Right? So what is decomposition? Let me write a reaction. Yes, this is decomposition redox reaction. How? Now this is plus 5, minus 1, minus 2 and 0. Here you can see chloride is reduced. Chloride is reduced from plus 5 to minus 1 and oxygen is reduced from minus 2 to 0. Oxygen is reduced from minus 2 to 0. So guys, here what is going on, actually reduction of chloride is taking place and oxidation of oxygen is taking place and exchange of electron is occurring within the atoms of same molecule. Here oxygen is losing the electron and chloride is gaining the electron. So because it occur between the atoms of same molecule, that is why it is called intramolecular. You might have heard about intra. Intra-school quiz. Yes. What do you mean by intra-school quiz? Intra means within. Intra means within. So this is the quiz competition within the school. And if there is inter-school, then it will be between two or more. Right? So intra-school quiz competition. Similarly, intramolecular. Intramolecular means within same molecule. So exchange of electrons is taking place between the atoms of same molecule. Here exchange of electron was taking place between two different molecules. That's why we called it intermolecular. But here exchange of electron is taking place within the same molecule. Actually, there are two atoms in the molecule. One is oxidizing and other is reducing. So exchange is occurring within the molecule. So I'm calling it intramolecular. Okay, guys, note it down. In decomposition reaction, there will be only one reactant in decomposition reaction, there will be only one reactant in which atoms of more than one element will be present. Right? Yes. Yes, Anjali Roy. Very good. So what is decomposition here? There will be, how will you identify the decomposition reaction? So there will be only one reactant in which atoms of more than one element will be present. In this case, we have chlorine, we have oxygen, and atoms of one element will be oxidized while the atoms of other element will be reduced. Here if I am writing -2 and +5, so you can see here oxidation, reduction. Yes, yes guys, so is that clear now? So can you identify the decomposition reaction, guys? Tell me, can you identify the decomposition reaction now? How many of you can identify that? Okay, okay. So guys, here you can write it down. This is decomposition reaction. This is again decomposition reaction. How? Yes. Here you can say this is +6. This is +6. Sorry, +3. And this nitrogen is -3 and this nitrogen is 0. So again a single molecule on heating giving you Cr2O3 and 2NH2. Just note them down. Right? Is that done now? This is also done. So you know, now note it down why it is called intramolecular. Yes, because exchange of electrons, note it down guys, occur between atoms or within atoms of same molecule. That is why it is called intramolecular redox. Yes, note it down. Because exchange of electron occur within atoms of same molecules. That is why it is called intramolecular redox reaction. Guys, please ask if you have any doubt. Please ask. No doubts? So now I have told you what is intermolecular. I have told you what is intramolecular. So another name of intramolecular is decomposition. So now I'm moving disproportionation. Yes, guys, this is disproportionation. Can any of you tell me what is going on in this reaction and how it is different from decomposition? Yes, be fast. What is different in this? Yes, guys, tell me why this reaction is different from others. Tell me, guys. Now it is saying 0, -1, +5, right? What is going on? What is the difference between disproportionation and decomposition? Yes, guys, because here also I am seeing only one reactant, and in this case also I was seeing only one reactant. So what is the difference? Yes, Anjali, Amy, anyone? The shorts guy, anyone? I'm waiting. Yes, guys, I'm waiting for you. Be fast. So, guys, what is going on? Let me tell you here. In no, in this case, it is easily understandable. Like chlorine, reduction of chlorine is taking place, and oxidation of oxygen is taking place. So, guys, one element is being oxidized and another element is being reduced. So there are basically atoms of two different elements. So basically there are atoms of two different elements. But in this case there is only one element, bromine. There is only one element. And some atoms of bromine are reduced, reduction, and some atom of bromine are oxidized. Yes. Some atoms of bromine are reduced while some other atoms of bromine are oxidized. Yes, tell me now. Yes, guys. So the difference here is that atoms of bromine are oxidized as well as atoms of bromine are reduced. So atoms of same element are being oxidized as well as reduced. But in decomposition, what was going on? Atoms of chlorine, reduction of chlorine atom were taking place and oxidation of oxygen was taking place. So guys, this is the basic difference. Many of you don't know about it. Many of you. So I hope now it is clear. So in this case, bromine is converted into bromide. Bromine is going into this. Yes, tell me, guys. Any doubt, please tell me. Done. So guys, this is also an example of disproportionation. Why? I just told you in beginning of today's lecture that H2O2 is converting into H2O. Balance the oxygen atom. So oxygen is going from -2 to -4. So reduction is taking place. O2. Just add them. Yes. So again here you can see, guys, why it is disproportionation. Let me tell you. Here reduction of oxygen is taking place, and here again oxidation of oxygen is taking place. Hydrogen is not involved in oxidation or reduction. So again, this is the case of disproportionation. So in disproportionation, atoms of same element is being oxidized and reduced. In decomposition, atoms of different elements are there, right? So what is disproportionation, guys? So guys, it consists of only one reactant, and if other reactant are present, then those will provide necessary acidic or basic medium. They will not participate in reaction, like they will not exchange electrons. They will just provide basic medium, in which atom of same element, very important point, in which atom of same element will get oxidized as well as reduced, will get oxidized as well as reduced. Done. So like, balance this. Yes, balance it. Then I will explain you. Actually, this is the same reaction. Balance it, guys. And I know every one of you can balance it. I've taught you how to balance a redox reaction. I've taught you, guys. Yes, be fast. What VD? Bore हो रहा है यार. What do you mean by it? So guys, when you are balancing it, iodine, you will convert it into 2Na, 0 to -1. So I will write 2 electron here. I will get it as this. Iodine. So balance the iodine here. 0 to +5. So there are 2 iodine, so +10. So just multiply it by 5. You will be getting 6 iodine and then 10 NaI and 2 NaIO3. Right? So we have 10 into 12. Yes, now this is balanced. So guys, again in this problem you can see here reduction of iodine is taking place. Here oxidation of iodine is taking place. So again, only atoms of one element are being oxidized as well as reduced. But one more molecule is present here, that is NaOH. So that molecule is just providing necessary acidic or basic medium. That molecule is just providing necessary acidic or basic medium, right? And how it is providing? So now just go through the definition again. Now you will understand it better. So disproportionation reaction, it consists of only one reactant, and that reactant is iodine. If other reactant is present, that other reactant is NaOH, then this will provide necessary acidic or basic medium. Yes, it is providing basic medium, right? So when it is providing basic medium, it will not undergo oxidation or reduction, in which atoms of same element will be oxidized as well as reduced. So guys, now you know about disproportionation. So what is conproportionation? So it is reverse of disproportionation. Why? So how? Now I'm telling you. Just write down this reaction. Giving you iodine. This is 0, -1, +5. So again here you can see oxidation, reduction. So guys, oxidation as well as reduction of iodine is taking place, but this time iodine is on the right side. So I cannot say only one reactant will be there. Here there will be more than one reactant. So you can just remember it like reverse of disproportionation is called conproportionation. Reverse of disproportionation is called conproportionation. Yes, any doubt? Any doubt, guys? No doubt. So now I'm moving to the next part, that is non-redox reaction. So what are non-redox reaction, guys? Non-redox. So there are four reactions: acid base, double displacement, decomposition, and complex formation. So what is acid base reaction here? If I am writing HCl plus NaOH, it will give me, yes, this is acid base. And what is double displacement reaction, guys? Tell me, what is double displacement reaction? If I am writing AgNO3 plus KCl, the reaction will give me, and this AgCl is solid. This AgCl is solid. So guys, in double displacement, you know, chloride ion is displacing nitrite ion. So in all these reactions, there will be no change in the oxidation state. That's why they are called non-redox. And what is decomposition reaction? On heating, it will give you. So if you find out their oxidation state, +2, +4, -2. Again, guys, you can see there is no change in the oxidation states. There is no change in the oxidation states. So guys, here you can say CaCO3, decomposition of CaCO3 is non-redox. However, decomposition of KClO3 was redox. Why? Because oxidation state of chloride and oxygen was changing there. And now what is complex formation, guys? If you are writing KCN and FeCl2, then you will be getting K4 FeCN6. This is called complex. So these are all examples of non-redox reaction, guys. You can note them down. Note them down. And now it would be easy for you to identify a redox reaction and non-redox reaction. Right, guys? So this is all. Today we have done some balancing problems. Then I told you the types of reactions. And now, guys, I'm moving on to the law of chemical equivalence. So guys, can you tell me how many of you know about the law of chemical equivalence? How many of you know about it? Yes. Can you tell me, guys? Law of chemical equivalence. Nobody knows. Actually, it is very important. And why it is important? Because if you know the law of chemical equivalence, then you don't have to balance a chemical reaction completely. Okay. If you know the law of chemical equivalence, then you can find out the amount of product without balancing the reaction completely. So today I will be teaching you law of chemical equivalence. So what is law of chemical equivalence? Right? Suppose this reaction is taking place. Guys, how will you read this chemical reaction? How will you read it? When I write like this way, how do I read it? Tell me. I read it like 1 mole of this reacting with 1 mole of this to produce 2 mole of this. And I can say 1 mole of hydrogen will give you 2 mole of HI. But to say this thing, I have to balance this reaction. And here if I am writing this reaction, I will say A moles of A are reacting with B moles of B to produce with C mole of C, D mole of D. Right guys? I can say it. A moles of A reacting with B moles of B to produce C mole of C and D mole of D. Any doubt? No doubt. So guys, I can say A mole of A produce C mole of C, 1 mole will produce and then X mole will produce. Again I have to balance it. But in case of law of chemical equivalence, I will always write whatever be the coefficient. Here A moles of A are reacting with B mole of B. But law of equivalence says equivalent of A reacted are equal to equivalent of B reacted are equal to equivalent of C produced is equal to equivalent of D produced. Right? This is called law of chemical equivalence. And according to it, equivalent of each reactant and each product are same, irrespective of its stoichiometric coefficient. So whatever be the stoichiometric coefficient, independent of that, equivalent will be same. Right? This is called law of chemical equivalence. So guys, according to it, during a chemical reaction, equivalent of each reactant reacted are equal to equivalent of each product produced, irrespective of the coefficient. So it has nothing to do with the coefficient. Even if you don't know anything about the coefficient, you can solve it. Right guys? You can solve it. So what are number of equivalent guys? When I am saying equivalent of A, equivalent of B, equivalent of C, equivalent of D. So guys, now question arises, sir, what is this equivalent? What is this equivalent? So equivalents actually are not the actual molecule or atom like we have atoms or molecule. These are hypothetical terms because equivalent of a substance may change if it is undergoing some different reaction. So what are number of equivalent? How will you calculate it? Number of equivalents will be equal to W upon E. W is the mass of substance given. And what is E? E is called equivalent weight. Now there is one more term. Sir, what is this equivalent weight? What is this equivalent weight? So equivalent weight will be equal to molar mass over N factor. So E will be equal to molar mass upon N factor. right? So number of equivalent, W by, and E I can write. So this is mole into n factor. So guys, if somehow you calculate this n factor, then you can find out the number of equivalent, right? So what is n factor? So in today's class and in next class, I will be telling you how to calculate n factor, right? How to calculate n factor and number of equivalent. Now you know this is equal to n factor into mole. Note it down. So you just need to calculate n factor, and number of equivalent are basically some hypothetical particles that we have assumed only for calculation purpose, right? So guys, now I'm moving to the next point. What is normality? What is normality? So if you know the molarity, what is molarity? In molarity we call NB over Vs in liter. So definition of molarity was number of moles per liter of solution. Number of moles per liter of solution is called molarity. So what is normality here? Number of equivalents of solute present per liter of solution. So normality you can write number of equivalents divided by volume of solution in liter. So what is number of equivalent? You know that mole into n factor, volume of solution in liter. So guys, mole upon volume of solution. Hi Harsini Ashwa, it will be molarity. So normality will be equal to molarity into n factor. So guys, everything is moving to n factor. What is this n factor, sir? What is this n factor? So now I will tell you the n factor and its calculation. What is this n factor and how to calculate n factor? Hi Dr. Harsini Ashwa. Yes. Tell me guys. What is n factor? Can any of you tell me the n factor? How many of you know about the n factor? Yes guys, tell me. How many of you know about the n factor? We've asked. Nobody. So now I will tell you guys. N factor, actually it has different definitions. N factor is different for redox reaction and its calculation is also different. And n factor is different for non-redox reaction, and the way we calculate n factor for non-redox is also different, right? So how do we do the calculation? Now I will explain you, but I'm giving you 2 minutes. If you guys have any doubt, you feel free to ask, and then I will proceed ahead. Yes, tell me guys. If you guys have any doubt, then please tell me. I'm giving you 2 minutes. About balancing of redox, about types of reactions, then about n factor, normality, and law of chemical equivalence. No doubt. So let's move ahead now. So I just told you that calculation of n factor is different Okay, calculation of n factor is different for redox and for non-redox, and the way to calculate the n factors will also be different. So guys, how will I calculate the n factor now? So let me tell you now. N factor for redox, and you know the redox. Redox reaction is the reaction in which oxidation number of atoms is changing. So if I'm writing like it, plus 7, it is gaining 5 electrons, right? So just balance only those atoms for which oxidation state is changing. So now you know that 5 electrons are exchanging, and if you know that 5 electrons are exchanging, just write down 5 everywhere, and now divide it by stoichiometric coefficient. So you will be getting n factor 1, 5 and 5, right? So n factor is 5 for it, n factor is 1 for it, and n factor is 5 for it, right? Any doubt? So what is n factor? Number of electrons lost or gained divided by stoichiometric coefficient of reactant or product. Note it down. Divided by stoichiometric coefficient of reactant or product. So I have divided it by 1, by 5 and by 1. So these are stoichiometric coefficients, right? So what is n factor? It represents the number of moles of electron exchange per mole of compound. You can also say that if n factor is 5 for it, means 1 mole of it is absorbing 5 electrons, right? So this is how we calculate the n factor. So let's do the calculation of n factor. So n factor will be 1, 5 and 5. Yes, tell me. Done? Okay. Is that done now? Now do the calculation of n factor for it. Do it. Calculate n factor for it. Yes guys, be fast. Let's see who can solve it. Do it guys. So I will write, there are 3 Mn here. See, oxidation state is plus 7 and here it is 8 by 3, right? Sorry guys. So Mn is undergoing change, plus 21, 2, because 3 into this, so 3 into 8 by 3 plus 8. So I will be getting 13 electron here, right? And when I am writing 13, so just write 13 everywhere. Any doubt? Done? But I did not get even a single correct answer. Why you guys could not solve it? It was easy problem. Even you can verify law of chemical equivalence. So number of equivalent will be equal to n factor into mole. So here we have 3 mole and n factor is 13 by 3. Here we have 13 n factor. Here again n factor is 1. So guys, here I can say that equivalent of electron will be equal to equivalent of MnO4 minus will be equal to equivalent of Mn3O4. I'm writing only half reactions so that you can understand, but I have already told you only oxidation half or only reduction half is not possible, right? But here for understanding purpose I am writing. Yes, yes, gaming. Where are you confused? Tell me. Where are you confused? Tell me now. Right? So now let's do it. Yes, guys. Here we have 2. So coefficient should be 2 plus 6 plus 3. So chromium will go from, so there will be gain of 6 electrons. Yes. Okay, gaming. Now this is the n factor for it. Again, you can write equivalent of electron, equivalent of Cr2O72 minus Cr3 plus. It will be 1 into 6. All equivalent are same. Done? If it is done, now solve this one. Now solve this one. Yes, gaming. So guys, you have to balance the oxygen. It is balanced now. Gain of 2 electron. Yes. Now it is done. No gaming. Your answer is not correct. Just see what I have done. Just see it. Okay. Now I'm moving on to this. Do it. Solve it. It's a very good problem. I will give you 2 minutes. Okay. Okay, gaming. Then it is okay. Now do it. this part. Do it, guys. I will give you 2 minutes for it. I'm waiting for your answers, guys. Yes, still I'm not getting answers. So how will you write it? +2, +3, +4. +2, +3. So just balance the iron, one iron, two carbon, two CO2. Just check how many electrons are changing their place, because in this compound more than one atoms are oxidized. More than one atoms are oxidized. And if they are oxidized, guys, now what will happen now? Fe is going from +2 to +3. Carbon is going from +3 electrons. So there is total loss of 3 electrons. Yes, this is tough. Now do it. Now you will write 3, 3, 3 and 3. You will be getting 1. So n factor will be, so n factor of electron will always be 1. Note it down. N factor of electron will always be 1. Any doubt, guys? No doubt. So just do the proof of law of chemical equivalence. Do it. Do it, guys, fast. So you just have to balance it and prove that equivalent of each reactant are equal to equivalent of each product. Do it. Yes, guys, do it. Yes, I'm waiting. Do it, guys. So you will just write Mn for giving you Mn2 +3. So carbon is moving from into 5. Just balance it. So you will be writing 10 electrons are here because 10 electrons are cancelling. This. So guys, what is law of chemical equivalence? According to it, equivalent of each reactant should be equal. Right? Equivalent of each reactant should be equal. And how can they be equal? So moles are 2, n factor is 5, n factor is 2, n factor is 1, n factor is 5. So here moles are 5, 10, 2. So guys, here you can see it. Equivalents of each reactant and each product are same. So I'm proving my point. Whatever be the coefficient, here you can say 2 moles of our KMnO4 are reacting with 5 mole of it. But in terms of equivalent, you will say equal equivalent of KMnO4 will react with equal equivalent of S2C2O4. Yes. Any doubt? Any doubt, guys? No doubt. Is that done now? So this is all about n factor. Next class I will start calculation of n factor and then we will practice some problems. Okay guys, so this is all for today guys. This is all for today, and next session would be filled with problems, so many concepts. But if you want to understand that properly, then please revise it at home. And guys, if you have really liked today's session, then don't forget to share it and like it, right? Please like and click on the bell icon so that you can get latest notification of our video lectures, right guys? And once you have liked it guys, then again I will tell you how to subscribe to Unacademy guys. Just click on the, after installing the Unacademy app, then click on the plus and you will be getting IIT NEET UG, then check IIT and hit the subscription button. Once you are hitting the subscription button guys, now I'm telling you, last 2 days are left. 2 days. 2 days are left guys now. Thank you Game Gaming. Thank you for your compliments. But revise it before coming to the next class. Otherwise you will not learn it. Right? So guys, if you really want to learn it, and if you are interested in joining an academy subscription plan guys, 2 days are left, and after 2 days guys there would be price hike. So I'm telling you what will be the difference. Currently for 1 year program you have to pay just 27,000 per annum after applying my code, that is Rahul Camp. Don't forget this code. But after this you have to pay 34,000, 7,000 more after 10th September. Okay guys, and then for 2 year program currently you just have to pay for 2 year guys, I'm telling you 32,000. But after fee hike you have to pay 50,000. You have to pay 50,000. So guys, that's why I'm telling you this is the right time if you want to subscribe, right? And once you are subscribing to an academy guys, now only 1 day is left. Okay, today is 8 or 9. Oh, it's 9. Only 1 day is left. Yes, game gaming. So guys, now let me tell you again, this is my code Rahul Game. If you are applying it, you will be getting flat 10% off. And once you are part of plus program guys, then you will get access to video lectures and content of all educators. And every fourth class would be doubt clearing session. There would be weekly quizzes. There would be weekly quizzes. and then we have mega quiz after each and every topic. And guys, there would be regular tests are very important part of any competitive examination, and there would be regular tests. So guys, I'm telling you, do it before tomorrow, and this is last chance. So guys, I will again meet you in the next class with so many new concepts and everything. So guys, take care of you. Bye bye. Thank you.